Last video, we were working to complete our cross-country flight planning for a trip to Mason City, Iowa, to visit Clear Lake and the historical sites for Buddy Holly. As I started brainstorming, planning, researching, and testing, I realized there were a couple of other skills necessary for completing the navigation log. A critical piece is how to go from true course to compass course, and how to determine ground speed from true airspeed and the direction and velocity of winds aloft. So, for this video, we will explore the 5 questions necessary to take true course and the winds and temperature aloft forecasts, and turn them into a compass heading and a ground speed suitable for using during cross-country planning. These questions are: 1. What is my true course? 2. What is my wind correction angle and ground speed? 3. What is my true heading? 4. What is my magnetic heading? And one more question where the FAA has published some contradictory information. In this video, we'll be using an old-fashioned plotter and a manual E6B, sometimes referred to as the whiz wheel. Why? Well, doing wind calculations on the E6B helps make each component more visible and helps demonstrate how they fit together. Let's walk through these questions one by one. The first question is, what is my true course? This is probably the easiest of the questions to answer. Since VFR sectionals are aligned with true north, the course line you draw on the sectional represents the true course. And to get the actual true course bearing, we'll use a plotter. To use a plotter, find a spot where the course line crosses a line of latitude or a line of longitude. Put the center of the protractor right where the course line and the line of latitude or longitude cross, and then align the ruler portion of the plotter with the course line, and read the true course bearing where the latitude or longitude line crosses the end of the protractor. In our case, the plotter shows our true course from KRST to KMCW to be 219 degrees. Simple, right? Let's move to the second question. What is my wind correction angle and ground speed? We'll use the true course and the winds aloft forecast to calculate our wind correction angle. Since we've decided to fly at 4,500 feet and the forecast only shows 3,000 and 6,000 feet, we'll need to estimate the winds. To do that, we'll take the average of the wind direction and the average of the wind velocity. For this example, we'll use the Rochester winds aloft forecast. So, for the direction, we'll add 320 and 300 and then divide that by 2, and that gives us 310 degrees. For the velocity, we'll add 5 knots and 17 knots and divide that by 2, and that gives us 11 knots. Now, we'll use the backside of the E6B to do the next 2 calculations. First, set the center grommet at 100 knots and put the wind direction at the top arrow. In our case, the wind will start at 310 degrees. Second, draw a line straight up from the grommet to represent the velocity of the wind. Since the wind velocity is 11 knots, we'll draw the line from the grommet to 111 knots. Finally, turn the dial at the top to our true course of 219 and move the end of the line we just drew until it's at the true airspeed found during our fuel and true airspeed calculations. In our case, if you remember, that was 123 knots. Now, count the number of degrees between the center line and the end of the line we just drew. This will be our wind correction angle. And in this case, the line we drew ends at 5 degrees to the right of 123 knots. If it were to the left, it would be minus 5. However, since it's to the right, our wind correction angle will be plus 5 degrees. And, as a bonus, we can use this same E6B position to estimate our ground speed. Once the end of the line is placed on the true airspeed, you read the estimated ground speed under the grommet. And in our case, the wind is a direct crosswind, and therefore our E6B shows that true airspeed and ground speed will be the same, or 123 knots. Now, don't forget this number because we'll need it when we finish filling out the navigation log in a later video. Now that we have our true course, wind correction angle, and ground speed, we can easily answer the next question. And that question is, what is our true heading? To find true heading, we'll need to add true course and the wind correction angle. In our case, it's 219 plus 5, and that equals our true heading of 224 degrees. Well, that was easy. The fourth question is, what is our magnetic heading? To answer this, we'll look for the local isogonic lines. These are magenta-colored dotted lines that run mostly top to bottom on the sectional. If the magnetic declination is to the east, you'll subtract the value. If the declination is to the west, you'll add it. However, in our case, the nearest isogonic line shows the declination to be 0 degrees. So, for this portion of the United States, true heading and magnetic course will be exactly the same. So, there you have it. In order to fly our true course of 219 degrees, we'll need to point the nose of the aircraft to 224 degrees magnetic. Here is the bonus and contradictory piece of information. There used to be a sixth question. What is the compass deviation? In the fleet of aircraft used for training, many magnetic compasses have an error or deviation card that shows compass errors at different bearings. In our case, the card looks like this. There also used to be Regulation 14 CFR 23.1547 that required the placard to be placed on or near the magnetic direction indicator, showing the calibration of the instrument in level flight in terms of magnetic headings of not more than 30-degree increments. In English, the regulation meant that you needed to have and use the deviation card and therefore needed to consider deviation when flight planning. However, in a 2017 Notice of Rulemaking, 14 CFR 23.1547 was canceled. So there is question about whether we need to include magnetic deviation in our calculations. However, since Chapter 16 of the PHAC describes using deviation, and the ACS notes that you should be able to demonstrate the use of any equipment located in the aircraft, if there is a deviation card in your airplane, you may wish to include it, or at least have a really good answer prepared about why you don't. In our case, the card notes the deviation between 210 and 240 degrees is, at most, 1 degree to the west. So, if we're going to use compass deviation, we'd steer to compass heading 225 rather than heading 224. Simple. So there you go. 5 questions and some bonus information. But we aren't done yet. To complete flight planning, you'll also need to watch the next video. If this video was helpful, please click the thumbs up and consider clicking subscribe. Also, in the comments section, please let me know if you plan to use magnetic deviation and why. Finally, please share this with 2 friends who might be struggling with cross-country planning. And, as always, thank you for watching, fly safely, and I'll see you next time.